Okay, here we go. So today we're going to talk about, my name is Adrian Smith, and today we're going to talk about building simpler user interfaces with or without membrane. So if you're interested in membrane, this talk will give you some background for the ideas that drive the design of membrane. But I hope this talk will be useful to you, even if you never use membrane. Hopefully this can give you a mental model that's useful for you to build user interfaces. So I feel like every once in a while, someone will pop in the Clojurian Slack and say, I'd like to build a simple user interface. And the response that they get is something along the lines of like, here's your machete, welcome to the jungle. And there's this great quote by Joe Armstrong where basically he's saying that with object-oriented programming, there's this problem where you want a banana, but the only thing that's available is a gorilla holding a banana deep in the jungle. And so a lot of times I feel like that's what UI programming feels like. And in this talk, I think one of the problems that we face with UI programming is that we're still kind of trapped by object-oriented programming. So this talk will hopefully cover some of those ideas, explain why they're a problem and how to fix them. And so one of the questions is, why have another UI library? I think a lot of UI libraries are focused on, I need a web app ASAP. And that's a good problem. That's an important problem. It's one a lot of people are interested in, but that's not what membrane is focused on. So the problems that membrane is focused on is that UI programs are complicated. I would argue that they're unnecessarily complicated. UI programming often feels weird. UI programming is still stuck in an object-oriented paradigm. And I think there's still a lot of big challenges left. I think there's a lot of unsolved problems. And so that's why I think there's room for more UI libraries. To kind of flesh out some of the problems that I was thinking about when building membrane, a big one is reusability. So user interfaces are often coupled to specific platforms, environments, and libraries. UI components, which should be, or often given as the building blocks for user interfaces, they often don't compose. And if you see a UI component that you would like to reuse, even if it's in the same, if it's another framework, there's basically no hope. Even if it's in the same framework, you often can't reuse it. And even within the same code base, a UI component is often not reusable unless you rewrite it in a non-idiomatic style. There's issues with brittleness. Testing, verification, and correctness are often things that are either skipped or there's not really a clear way to handle testing, verification, and correctness. There's pervasive state. In a typical UI application, there's usually global state. Your framework is keeping track of state. Each component has access to the database, its own local state, has props. And on the web, there's the DOM, but even if you're using CLJFX or React Native, the underlying object-oriented system also has its own state. So there's state, there's multiple layers, and at each layer, there's also state. There's visual bugs. And there's a question of like, can you even do unit tests? What would that even look like? There's a huge problem with coupling with UI frameworks. That goes back to the coupling and reusability are connected. UI programming is often dominated by frameworks as compared to most Clojure programming where you have simple libraries. For membrane, I get asked this question like, how do I do X and Y? So it's like, how do I send a network request in membrane? Or how do I do async events in membrane? And the answer to that I think should be given is, how do you normally do that? If you want to do async requests, membrane shouldn't get in your way. On the right here of the screen, there's a website called Testing Library. And has a list of the testing library for each framework. So every framework rebuilds a new testing library. Maybe there's some shared code, but there's a lot of redundancy here. New framework, new testing library. And it's the same thing in the ClojureScript world. So this is reframe. I do want to point out that I think like I said, I think Reframe and Fulcro are really good libraries for building web apps. I'm going to talk about how Membrane does some things differently, but the point isn't to beat up on these libraries. It's really to just point out the differences. And I think these libraries are really good, and I think their communities are great. I've talked to their authors, and they're also great. But I do, there are some things that Membrane does differently that I want to point out. And so this is the external resources page for Reframe. And there's these plugins that deal with storage, Firebase, cookies, HTTP requests, and all of these are coupled to Reframe. And it's the same story typically for any framework that you use. So there's, React has its own thing, Reagent. Every framework has its own stack, and they don't compose and you can't reuse them. And as you were saying with reusability, components are also very complex by themselves. They have lifecycle, they have graphics, they talk to the database, they have their own state. Often they do stuff with timers, animation. And so they're supposed to be a building block, but they're really complex by themselves. And there's even bigger problems that some of these, I don't think, some of these things are, I don't know how to solve some of these. I'm trying to work towards with Membrane, but I think it's important to at least think about the bigger problems and where you want to go in a larger sense. So the first problem, and I think if I could solve one problem with Membrane, it would be that designers are out of the loop. And what I mean by that is that typically you have a UI, or a common workflow is you have a UI designer. They design a user interface in Sketch, Figma, Photoshop. They hand it to a programmer who implements it. It goes to the user. And if there's problems with how it looks or feels, the designer is completely powerless to fix it. They've got to hope that the programmer did everything right and implement it well. And I think this is a huge problem. I think designers should have direct control over their output. And I think that's possible. I don't think there's anything special about UI programming where we can't give that control back to designers. Vertical integration of apps and UIs. So I think in programming, we're a little bit spoiled because when I'm working with code, I can choose what user interface, what code editor I want to use. And there's also simpler services, like if I use email, I can choose my own email client. But there's a big problem generally, which I don't know how to solve, but I think it's still a big problem, is that if I have a program that has formatted text like Slack or Twitter or what have you, Twitter or Slack provides that formatted text interface. Every web page I go to has its own payment input form. And I think as a user, I would like to be able to use the UI that I want to use, like I can with my email client or my code editor. We're moving to a world with more screens, more devices, more inputs. So it's not just mouse and keyboard anymore. You have accelerometers and other new input devices. There's new outputs, so audio and haptic feedback, and there's other types of output, more devices there. And then accessibility, I think, is still a huge issue that we, even if you follow all of the guidelines, I think it's still a pretty low standard, and there's a lot of room for improvement, and we could do much better than we're currently doing. So to break down this problem, I think it's good to take a step back and ask what a user interface is. So this is what I call the functional UI model. And I don't think, hopefully this isn't, I don't think there's anything here that's too surprising, but I think it's important to understand each of these pieces. So we'll go through the whole diagram here. So triangles are pure functions. Triangles are functions. If they're black, they're pure. If they're red, they're impure. And then these circles are immutable values. So this diagram starts over here with the initial state. So actually going back one more. And then this diagram has three major pieces: the application, the user interface, which is defined by a view function and event function, and then a graphics backend. So we'll go through the flow of how this model works. So you have an application, which is seeded by initial state. The relevant portion of the application is given to the view function. which takes the state as an argument and returns a view, which is an immutable value representing what to draw. That's passed to the graphics backend, which displays it on the monitor. The user gets excited, uses the mouse or keyboard to produce an event, and an event is just like a mouse click or a keyboard press. And the event function takes the last presented view along with the event and returns user intents. So I use the word intent here for this representation, and an example of that is if you click on an add to do button, the intent is add to do, and that's just a description of what the user was intending when they clicked on the mouse. Other frameworks also have this. Typically, they're called effects. I prefer intents because it's more of a what, and effects is more of a how. But these are both interchangeable, and if you use other libraries, effects may be a more familiar name. And the effect is passed to the effect handler, which will carry out the effect, including updating the app state, maybe writing to disk. But now we're back to the beginning, and this loop can kind of continue. So some other important aspects of this model is that it's just a mental model. So this isn't necessarily meant to represent the full implementation. So things like memoization, which is technically a side effect, that doesn't change the mental model. So that's not what this is trying to represent. I think things like React's concurrent and rendering, which can complicate the model or can complicate the implementation. As long as you present a functional interface, it doesn't really matter. We're not really concerned with the implementation for this diagram. And another thing to point out is that I think I would argue that this model is universal. So it could be used to build any user interface you ever want to build ever. And so before, when I was describing that, we have this graphics backend that has the output, and I said usually that's a monitor with 2D graphics, but it could be 3D graphics. It could be other outputs like audio, haptic feedback, screen readers, smell-o-vision, any other output that is ever created. And then this model also extends to any other input. So accelerometers, hand tracking, head tracking, voice commands, DDR dance pads, joysticks, all of these can produce events that go back to your user interface. And then the last kind of key idea here is that these are, you use as much as possible, you use pure functions, and that's pure functions and immutable values, because that's what's going to allow you to decouple the different parts of your system. And the main idea of this talk is that if you use the functional UI model, then you're 90% of the way to fixing all of the problems, not the bigger problems, but all of the problems of reusability, coupling, and brittleness that we talked about at the beginning. And the problem we have is that we're not actually using the functional UI model. What we're actually doing is this. So the change might have been subtle. So the difference between the functional UI model and what we typically have is here in the user interface, the view, we don't have a data model, an information model that can represent views using immutable data. We don't have pure functions for our views. We don't have pure functions for our events. And the problem is that this couples, this introduces coupling through our system. And that's what we want to get away from. So at the center of our problem, where we'll start is talking about views, because really, this is where our problems start. And to talk about representing views as data, we also have to talk about this problem where most UI libraries are building on some sort of object-oriented technology. So UIKit on iOS, there's WinUI, Android, JavaFX, Swing, and then also HTML in the browser. And so I think we can recover the functional UI model, but if you're not considerate about what you're adopting and what you're accepting from these underlying object-oriented libraries, then it's easy to get to a point where you can't fix the problem. So the first question to ask is, where's the data? So for all of these underlying object-oriented options, all of them have a mutable, represent views as mutable data. They don't have immutable data. HTML is mutable, the DOM is mutable, JavaFX, everything's mutable, Swing, UIKit, GTK, every single one is old object-oriented mutable technology. And I think you might be saying, it's like, we know how to fix this. We have the solution. In the web, we have React, we have virtual DOM, and we can use that even with React Native. We can use that with everything else. We use virtual DOM, and that gets us back to the immutable data and values. So, but I don't think that's the case. So pop quiz. What's the width of a div? So if you create a div and ask what its width is, how wide is it? Can you measure it? Is it 0 pixels? Is it the width of its container? Is it whatever shows up in Chrome today? I think this is how we treat a lot of view data. It's like, okay, I opened up in Chrome, it's fine. Or is this a trick question? So it turns out if you ask this, if you go into your Chrome console and type this in, the div doesn't have any width. But the answer is actually more complicated. So if you add the div to the DOM, all of a sudden, now it's got the width of its container. So it's now mutated. And so and it's also connected to mutable state in the sense that, like, if you resize the window, this is now a different value. And so it's mutable all the way down. And the problem gets even worse than that. So if you go to the HTML living standard page for the div, I actually checked it this morning because it changed yesterday, and I was like, hopefully they don't break things for my talk today. But and I love that they called it the living standard. I think they're trying to tell us something. That anyway, so if you go to the section on what a div is, it tells you. It says the div element has no special meaning at all. So if you're building virtual DOM out of divs, and divs don't have any meaning, that's not an immutable value, because the definition of a value is not only that it's immutable, which if you're using virtual DOM, that is immutable, but for it to be a value, it must be semantically transparent and have precise meaning or significance. So when you're manipulating the virtual DOM, so I mean, once you put it in the DOM, it now has all this information available. It does have data about what its meaning to significance is. So once you put it inside the DOM, all of a sudden now you know how wide it is, how tall it is. There's all these other computed properties that are completely unavailable to you when you're manipulating the virtual DOM. So you have these two options where you have the immutable, but there's no meaning or significance, or you have the DOM, which has the information that you need, but it's kind of hidden behind an object-oriented protocol, and it's also very mutable, which causes other problems in the coupling and brittleness that we were worried about. So you can't. So that means you can't get that information. By the time you do, it's already too late. And so you have to go into the jungle to figure out what this thing means. So if we're not using divs, what should we be using? So if you go to, use any of the design tools, these are the toolbars from Figma and Photoshop. But if you go to any design tool, what you'll find that there's no div tool. There's no HTML tool. So even when designers are designing specifically for the web, on the web, they're still not designing in terms of divs and spans. The problem gets even worse where, so Skia is a graphics library. It's the graphics library that Chrome uses to draw all of the UI and all of the HTML. And if you look at the Skia API, there's no primitive. Skia does not know how to draw HTML. So the browser, what the browser does is it turns the HTML that's provided into shapes, text, and images. And so we have this problem where the designer is working in terms of shapes, text, and images. The graphics library is working in terms of shapes, text, and images. And in the middle, you have this meaningless gook that is mucking up all of our systems. And so this, I've been talking about HTML and in the browser, but you have the same problems if you're working with Swing or UIKit or any of the other object-oriented technologies. So again, what should we represent? We should be representing shapes, text, and images. That's really just a summary, but that covers most of, there's a lot of other things that you'll find in Figma and Photoshop that describe, but that's kind of how I summarize it. We should have generic interfaces for these elements so that it's open set and you can add more element types. And these generic interfaces that I've listed here are what Membrane provides, but I think this is a minimal set. So we can do much better than this, but at the very minimum, you want some sort of bounding box. So some way to measure the elements. If you're given an element or a collection of elements, you should be able to measure them. Some way to get the origin of the element. So you want to be able to move these elements around. You want to be able to, usually these are represented as trees. So you want to be able to get the children or branches of each element so you can recursively recursively traverse these trees. And we haven't really talked about the event model yet, but you also want an event model. And kind of a simple way to think about it is what to draw, not how to draw it. And so this is a way to kind of decouple your user interface from a particular graphics library or backend. And it also means that you're actually providing meaning and significance. And this is kind of a place where I think UI libraries could do a lot better. I would love to see more libraries and applications take on this problem of representing what their view is, what it means to be a view, and what that data is. Like if you use Ring, there's a data representation of what an HTTP request is, or if you use a SQL library, there's a data representation of what the SQL is. And if you look at a lot of UI libraries, this is just a missing piece. They've abdicated the responsibility, and they're using whatever data model was designed 20 years ago using object-oriented methodology. And so my suggestion to you is don't be intimidated by this. This is what we do all the time. We build data models for the domains that we work in. And I would encourage you to just go for it. It's really hard to do worse than HTML. So, go for it. And again, there's even, I gave a list of kind of a minimal set, but there's so much more we could be doing, and we should have more data and information and meaning available to our programs that are manipulating and building user interfaces. So graphic design has a long history of, we don't have to make this stuff up. We're not starting from scratch. Graphic design has a long history of giving meaning and describing what you see. And then we also have a lot of mathematics that goes into hit testing polygons intersection, which is important for event handling, which we haven't really talked about yet, but we will. And the last thing I'll say about the data model is that I did want to mention is that you may be saying, okay, maybe we're not designing in terms of HTML, but we still have this problem where we need to deploy to the web, because the web is one of the best, if not the best way to deploy applications. It's important for your business. And I think we can look to JavaScript as a model for how we can do this. So most programmers that target the web aren't writing in vanilla JavaScript. They're writing in some flavor of JavaScript or another language altogether, like ClojureScript, that's then compiled to the JavaScript that runs in the browser. HTML is just a bad graphics library. And if we had a bad programming language, we use a better one and spit out JavaScript. We should do the same thing for our graphics. This is really just a compiler problem. And yeah, I think there's some, I may be dating myself, but I remember you may have run, like a long time ago, somebody gave you some output from Dreamweaver, and then you have to figure out how to make that run efficiently in a browser. But browsers are a lot better. Compiler technology is a lot better. If membrane, I mean, there are really good libraries for building web apps like Reframe and Fulcro and others. So membrane doesn't really focus on the web, but if membrane was focused on the web, this is the first thing I do is I figure out how to build user interfaces with the same data model and spit out HTML. We're already doing it, although we're doing it all manually. It should be automatic. And I think I've heard the argument that it's hard to take a UI description that's provided by a UI designer and turn that into HTML. And I think that's just an argument for why we shouldn't be using HTML in the first place. Okay, cool. So now we have immutable data to represent our view. And so the next area I want to talk about is the view function here in the middle. So our user interface is built up of a view function and an event function. Our view functions are should be also pure functions, but they're not. And most UI libraries have components, and components are some, at least look like, or are some flavor of a function. And I don't know if you've ever tried to call the function that is your UI component. I actually had to go through a bunch of different libraries, build a simple component and call it. And it's like, does it need context? Can you call it? Does it, do you have to build in an environment before you can call it? Do you have to walk into the jungle before you can even call this function? And I think the reason we stopped calling, I think it's actually really rare to actually call this function. What most people do is you build up this components and then you give it to React. And the reason is because, I mean, one, these components return a variety of things that most people don't worry about because they never call them, but usually they return eventually some sort of React component. And the reason we don't call these functions is because if somebody tells you they have a div, there's not really much you can do that. If you have a React component, there's not really any useful thing you can do with a React component except for give it to React to plug into the DOM. So we stopped calling functions, we stopped worrying about return values. And then when we stopped calling these functions, we also stopped caring about passing data through arguments. So it's really common for UI components for, instead of gaining the data that they use from their function arguments, they get it from some sort of side channel, like a subscription or an atom or some other place, some directly from the database. And I mean, having side effects is one of the main ways one of the main routes to coupling. And we should be using pure functions where you take data, return data. But once you start putting side effects inside your component, you're now coupling parts of your system and you can't reuse them. And even so, if you have a component that has a reframe, has a atom in it, it's dereferencing, don't put that inside your component, put it on the outside, turn it into data, pass the data to the function and get a return value. And so, and I think there might be a question of what to return, but I think the question should be obvious by now, is that components should be returning immutable views. And I think when we stop calling functions, we stop caring about return values, we stop caring about, I mean, warning bells should be really going off when you see this. And I think there's programmers who work in all parts of the stack, but they won't go near user interface code. They're like, jungle living is not for me. And this is the kind of stuff that we've gotten used to that I think we need to start moving away from. And I think, I mean, I think the libraries that do this, it's not really their fault because it's, because really, if the return value, if you don't have immutable data to represent your view, who cares? It's like there's no point in calling the function anyway. So it doesn't. Unless we fix that problem, we can't fix this problem. And so components should be reusable and replaceable. I think Storybook is an example where we enforce this on ourselves so that we have some way to get these reusable pieces. And I think one of the goals is for reusability is how can you, what does it mean to say like, okay, I'm looking for a component that fits these requirements. So if your component is a pure function that takes data and returns data, there's all these different ways to say this component is compatible, or this is the kind of component I need, build this component, or here's a reusable component, here's what it provides, and here's what it expects. Because we know how to do this with pure functions. But if there's, if you have a date picker and it's directly using side effects and state, and there's some stuff is from function arguments and props, some of it's coming from the database, it's really hard to say, here's this reusable thing. And they should be reusable. This isn't magic. We do this all the time on the back end where you have data in pure functions, stuff is reusable. And Membrane already does this. So in Membrane, components are pure functions. And if you want, so there's a demo example. If there's one macro that can turn any Membrane component into a Java effects component because, or a CLJFX component, because CLJFX components and many other libraries like it kind of couple the state on the inside of the component. And so if you have a pure function, you can take some state and call the function. But if they're coupled together, you can't go the opposite. So in many cases, Membrane components can be used and embedded inside other frameworks, but the other way isn't really, you can't really go the other way unless there's some way to get a pure function out of it. I think there's still some open questions here about how to deal with styling and replaceability, but until we have data and pure functions, you really even can't, there's not even a way to talk about it. So this is the direction we should be going. Okay, and so yeah, now our view function is a pure function. Our view is returning data. Now let's talk about the last piece of the user interface, which is the event function. So this is a little bit harder to talk about because in some ways this is event handling is, I mean, a lot of UI libraries provide things for components, and they provide some way to represent HTML or whatever virtual DOM they're using. But the event model is in large part determined and specified by the underlying object-oriented framework. So there's less of an analog. And I think, I don't know, yeah, this explanation should probably be longer, but we don't really have time. But on the top here, we have an on-click handler for something, for most, what looks like for most UI frameworks. So basically, you get somebody clicks the add to do button and you immediately dispatch the side affecting effect. So you're directly connecting the event with the effect and what's happening. On the bottom here is what it looks like in Membrane. So I don't think this is the only way to do it, but hopefully it at least gives you a concrete example. So you have a button with an on-click handler, and instead of immediately dispatching the effect, you just return the intent. And here it's a list of intents. So that's why there's the double square brackets. And event functions. So this is the event function for a mouse down event. And so you can call your component, it returns a value. We're seeing what happens when you click at the at the mouse position 0, 0, and it returns add to do. So this is your event function. It takes the view and the event and returns the intents. And this is, it's a pure function and it's naturally decoupling. I think if this doesn't make a lot of sense, I think that's not unexpected. The main things that I would point out is, again, here, we're ignoring return values. We're ignoring return values. So we're supposed to be doing functional programming, but we're ignoring arguments and we're ignoring return values. And I think that should be kind of a warning that maybe there's a better way to do it. And I know that it's really, there's this idea of lifting state up. So instead of directly calling the add to do effect, you can instead pass in a callback in many of these frameworks that's like, here's the add to do callback. And again, I want to just appeal to your programming sensibilities, your spidey sense that we're ignoring return values. And what would you rather deal with? Would you rather deal with a pure function or a bunch of callbacks? So yeah, I don't think this is necessarily going to convince you, but you should at least be interested in replacing a bunch of callbacks with pure functions. So we've now talked about all of the major pieces that we've messed up. And so, but I do want to give a few more examples that kind of explain why, help flesh out why this is a problem. I mean, I think we've already covered several that should be compelling, but there's a few others that I wanted to mention. So in the browser, there's only the main thread. And part of it is this problem is that you can't, everything's coupled together, everything's mutable. So the way to fix that is like, you can do locks or some other coordination mechanism. But what everybody does, this is in the browser, but this is all the other UI frameworks, is they just do everything on the main thread. And I think one of the reasons UI programming is dominated by frameworks is also related to this, where not only does everything have to be run on the main thread, the UI library that you're using has to be in charge, because when it's about to do layout and then eventually repaint the screen, it needs to make sure that nobody else has access or is mutating the underlying representation. And so you get this thing where don't call me, I'll call you. And so you get frameworks and you bake in all these choices about layout and lifecycle, and it has all these effects on latency because since everything is on the main thread, all these things, all these different responsibilities are competing with each other. And using immutable data and pure functions, we already know from other areas where that it's naturally decoupling, and it kind of helps us write concurrent code that where you can stay sane and you can divide up responsibilities, and you don't have to do everything on the main thread. And another area, and this ties back to the previous slide, where everything's done on the main thread, because if you have a mutable representation, you need to make sure nobody's messing with it. And I think one of the areas where this is really obvious from my perspective is layout. Often I get asked, like, what layout are you going to use with membrane? What layout are you baking in? And there's no baked in layout system for membrane. Membrane does offer a suite of libraries or a suite of functions that help you do layout, but layout is just data transformation. You take views and then you move them around. It's just data to data. And the reason libraries don't let you do this is because they need to do layout right before they paint. And if there's no way to get a stable snapshot other than doing it on the main thread with them in control, they have to bake in all these layout decisions, and they can't, unless they provide hooks, they really they really have to decide for you how layout is going to be done. Whereas with membrane, it's just data transformation. So you can, there's multiple different ways to do layout. And not only that, it's just data. So here is a layout function that takes a transducer. Maybe you don't like transducers, you don't even have to use it, but it's just data transformation. So you can use all the suite of libraries that work on data, and you can reuse them for building user interfaces. And when you're doing layout, one of the things that you need to do is measure elements, so you know how much space they take out, so you know how to arrange them. And it's often that if you're building a complex enough application that you have to do all this work anyway. But you have to, unfortunately, you have to just do this on your own, and you don't have access to all the protocols that give you this layout information. So if you want to know how big some text is going to be when it's rendered, you've got to start over from scratch. And so my favorite example of this is CodeMirror. If you look at the CodeMirror code base, they basically have to re-implement all this stuff from scratch in userland because they need to do some complex layout, and they can't do it in terms of the layout that's provided by the UI framework. And it gives you a lot of, and doing this gives you a lot of flexibility. You can choose what algorithm you can, with the performance characteristics, you can do it based off your use case. You can do it ahead of time in the background. There's a lot of flexibility that you get. And so I think one of the interesting aspects of this perspective of the functional UI model is that you realize that most UI libraries aren't about user interfaces. So I think when we build web applications, there's the stuff that runs in the browser, and then there's the backend code. And we tend to think of, there's front end, back end, and everything in the front is the UI. But in reality, in the client, in the browser, you have an application, and the application also has a user interface. And the application needs a lot of facilities. It needs databases. It usually has its own database that it created just for the UI library. It does state management. It has dependency injection. It has lifecycle, networking, and a bunch of other stuff. And since the UI program, the way we've structured our UI programs, having a mutable view basically just starts, everything gets coupled together. And so you end up where not only is the user interface coupled, there's all this coupling in the user interface, it's coupled to the rest of our application. So on the server side, if you want a database, use a library. If you want dependency injection, there's a different library, and you compose libraries together. On the front end, we have this problem where our application, you get this framework that does all this stuff for you. And then if you choose a different framework, it's a completely different set of stuff. And so there's a lot of coupling. Instead, you should have a library. There's this problem. There's this question I get a lot with Membrane is like, how do I do this in Membrane? And it's like, well, how do you normally do it? Just do it the way you want. And Membrane, well, the goal is to offer you tools to help you do what you want to do and not make a bunch of decisions for you. And then the one big thing that's missing from most UI libraries is any data model for the view. This should be one of the primary responsibilities of UI library, is to give you some sort of data specification. Like I was saying, Ring has a data format for HTTP requests, but UI libraries just, they just don't have, this is a missing piece, and it's a big problem. So I do want to give you a sense of where Membrane is. And so when I started working on Membrane, I was also a skeptic that functional UI programming, you could really do it that way. I was thinking about user interfaces, and there's this kind of sense that it's complicated, it's unnecessarily complicated, that we could do better, but I wasn't, I didn't know where the problem was or what, how to fix it. And so I really wanted, part of working on Membrane is like, I want to know for myself, like, can we do this? Is there something weird about UI programming? Is this really the way it is, or can we do better? And I want to report back that we can do better. It could be simpler. I don't think Membrane does everything perfectly. I'd love to see more people work here. Membrane is still in beta. There's still some work to be done, but it does work. I was worried, at some point I'm going to run into performance issues, or there's some roadblock I'm going to hit, but I've now gotten far enough along that I've at least convinced myself that this is the way to go. Membrane runs anywhere. So it was never a design goal to be cross-platform or work on top of multiple libraries, but it turns out that if you represent your UI in terms of shapes, text, and images, it's really easy. It's actually kind of a fun, sometimes when I'm stuck on a design problem, it's like, oh, let's build another graphics backend, because it's really fun. All of a sudden your UI now works in a new place, and it's not as hard as it sounds. Membrane is designed, it's actually a collection of libraries. So if you want to start playing this game, and one of the problems with Membrane is that I had that problem where I wanted a banana, and I really tried really hard to reuse other libraries, but unfortunately, without a data model, there's all this coupling. So I couldn't get the banana. I couldn't get just this one simple piece. So I had to, in large part, build a lot of simple pieces myself. But for you, my hope is that if you're interested in doing this and you think you can do some piece better, that you don't have to start it from scratch, that you can just use something from Membrane, or I can help you find something like it that lets you build just one small piece. I would love to see that Membrane eventually gets divided up and people build better libraries for different parts of it, and Membrane just disappears because there's other simpler libraries that do every piece better. I would love to see that. So not a roadmap, but kind of, I am working towards, in my mind, I have an idea of what I want for a 1.0 release. I don't know how far away it is, but for that, I want a direct manipulation UI editor. And right now, there's desktop, there's some basic web support, there's a demo that runs on iOS, and so I'd also like to have Android support. So that's kind of what I'm working on right now. And yeah, I think this is a huge opportunity. When we were talking about, this is really just applying functional programming to user interfaces. The problems that we were talking about is place-oriented programming, weak support for information, brittleness coupling, parochialism, context. And these are all problems that Clojure is designed to tackle. Clojure has great support for this, and it's a lot more fun. I think for a lot of UI programming, there's this sense of like you're trying to swim upstream, and just staying in place requires a ton of effort. But building things with pure functions and data in Clojure, a lot of times I feel like I'm floating downstream, where I go on vacation, I come back, and there's more libraries that work with data and produce data, and it's like I can use that, and it's great. And UI programming, I feel like, does a lot of weird stuff. I think it could be just like, I don't think there's anything special about user interfaces. I think we could be doing just regular programming. And I'd love to see more. I know there's like some fatigue with more with UI frameworks, but I'd actually love to see more simpler libraries. I think we need more of that. And like I said, I don't think it's a competition. It's like if you build something that takes data and returns data, I can use that, and it's not competing with my, that's just more stuff that I can use. And, we find this in Clojure, where if you use like meander and spec in the same library, no big deal. But trying to use a reframe component from Fulcro, it's like, there's this kind of competition. So I think this is a huge opportunity. Love to see more people doing it. And that's it.